Math Genie.
In this video, I'll be explaining how to solve casework problems. Let's look at the question. How many squares can be formed using 4 of the dots in the unit grid as vertices? This problem is very frequently tested in math competitions, and I always say this for every single one of my videos, but this one I have actually seen it in competitions, so I know for sure that this is actually very frequently appearing in competitions. So, how do you solve this? That's the main question of this video, right? So in order to solve this problem, you have to actually use the diagram below and draw the squares on the unit grid, right? You can't just mentally do this problem because probably 9 out of 10 times you're going to mess up in the middle because it's very easy to leave out 1 or 2 squares while counting. So I really encourage you to take notes on this video and see how you can approach this problem. Let's just start by looking for squares, right? Well, you see an obvious square that you can form right below, right? Which is the smallest square right here. And I'll indicate that with pink. This one is pretty simple, right? You have 9 of these because you can form 9 of these tiny squares on this unit grid below. Let's move on to the second largest one, which is the 2 by 2 square. This is again pretty self-explanatory. You have 4 of these on the grid, right? Because you can form 4 2 by 2 squares on the grid below. And the final obvious square that we can find is the one that includes the entire grid. And that is, of course, 1. And the mistake that students make is that they will just simply do 9 plus 4 plus 1 and just put 14 as your answer and just put it in the answer choice. Well, that's not going to be the answer because there are more squares you can form out of the grid below. Let me show you 2 more types of squares that you should be able to find or locate on the grid below. The first one the students miss is the one that is the radical 2 by radical 2 square, which is basically just connecting the 2 points here. So like that. Now let me actually zoom out on this, right? So if you actually just look at it from the forward view, this is what the square actually looks like, right? And the side lengths are just radical 2 and radical 2. And how do I know this? Let me zoom out on the triangle right here. Right here. Well, we know that this is a unit grid, so we know this is 1 and this is 1. So obviously, if we use the Pythagorean theorem, we can find that the diagonal or the hypotenuse here is going to be radical 2. So we know for sure that this is a radical 2 by radical 2 square. This is still a square because the problem never mentioned that the sides of the square have to be a whole number, right? So we can have radicals as our side lengths because it is still a real number. How many of these radical 2 by radical 2 squares do we have? We have 4 of them. So we just found 4 more squares. But we can't stop here yet because I can already see one more the students most likely miss. And that is connecting these 2 dots. Right here. How is that a square? Let me zoom out on it again. Make it a little bit more larger than the 2 by 2 one, or the radical 2 by radical 2 one. Alright, I just zoomed out of it again. Well, let's first locate the triangle here. You can see that there's a triangle right here, right? So And if we zoom on the triangle, this is obviously 2 and 1. So you should be able to find that the hypotenuse is radical 5 just by using the Pythagorean theorem. So we can find radical 5 by radical 5 square again. How many of these can you locate? Don't put 4. Try to look for how many squares you can form, and you'll get 2. So 214, you should add 4 plus 2, because you can find the radical 2 by radical 2 square and a radical 5 by radical 5 square. This is going to give you the answer 20. So the answer to this question is going to be 20 squares. Please make sure that you're counting all the squares using all the sides. And again, the only restriction that we had is we have to use 4 of the dots, right? It never said that the side lengths have to be a whole number, which means that we can use radical numbers for our side lengths. Thank you for seeing to the end of this video.
Math Genie.